Implicit differentiation. Here we go. We're going to study functions. Can also be derived with multiple variables. We take the derivative of each term. And solve for dy by dx. So we'll do a nice example of this. We'll bring back over that dy by dx stuff we did at the beginning of the year. It's all right if you're shaking your head. We'll go through it today just to make sure it's good. This is necessary for when there's complicated equations. The things we're going to talk about will be something like this. Okay? It'll be an equation to find the derivative of that. Anyone know what that equation is of? Circle. That is the equation of a circle. Okay. Why can I not just easily isolate for y in that equation, solve it like that? Why can you not easily solve that?
We have that as an equation for a circle.
Well, that's just the equation for a circle. That's what it looks like. That's what it is. Well, the problem is, let's say I isolate for y in that equation. What's y going to equal? Yeah.
25 minus x squared. So you still have that.
Good. And also y squared is equal to 25 minus x. What is y equal then?
5 minus.
Well, y, if you, let's go through here. I'll tell you the problem with this. Okay, so y squared is going to be 25 minus x squared, which is true. What is y equal then? So that's mass is what that is. Okay, because you're going to have many solutions. Excuse me. If you get the slope, right, radial slope and all that sort of stuff, it's going to be difficult. So we're going to find a new way called implicit differentiation we're going to use today to show you what about all that side stuff. Okay. Alright, because this is messy to deal with. So I'm going to start off with easy, which is example 1. Use Leibniz notation to find excuse me, the derivative of y equals x squared. Whew. Okay, so we'll go back to the beginning of the year. Just in English, what's the derivative of y equals x squared right from the beginning of the year? It's equal to what? 2x, so it's exactly this 2x. What we're going to do in Leibniz notation is this. We want to take the derivative of everything. We're going to take the derivative of y is equal to the derivative of x squared. Okay? The derivative of y is just dy by dx. And the derivative of x squared is just 2x. And that's all it is. Now the point is that I'm doing here is I'm taking the derivative of both sides. And that's what I'm doing here. Okay? The derivative of y is just dy by dx. The derivative of x squared is just 2x. They might say, why does this matter to me as a human being? I'm going to show you right now.
Why are you doing it?
What's that?
You're using the dy and dx.
Yeah, because for this part you have to. Right?
Like, I don't really get what it means. Like,
all I'm saying is the derivative of y with respect to x. And there was a small change in y compared to the change in x. If you remember what's the derivative in English? So what does the derivative tell you? Instantaneous change, which is slope. Right, so we're saying a small change in y compared to a small change in x is going to be 2x. That's what we're saying there. Okay? Let's get to why I'll show you why this is useful here for example 1. Example 2, I guess. Okay. Example 2 says, what is implicit differentiation? To solve, to find the derivative of x squared plus y squared equals 25. So what we're going to do is we'll take the derivative of each part. And you can skip this middle step in about one example. So you're taking the derivative of each part. Okay, let's start off easy here. Okay, so we take the derivative of the right-hand side for me. What's the derivative of 25 going to be? 0. Okay, what's the derivative of x squared going to be? 2x. And I'm going to leave this right now, and I'm going to show you where this comes from, because this is the tricky part of that. Okay? I'm going to use chain rule for this. And that's exactly what I'm trying to say here. And it's exactly what I'm showing why it goes on 2y. But the point is, so it turns into 2y. Okay, so what happened was, what else? Good question. So what happened was, I just split this apart. So I multiplied by dy here and divided by dy there. So I took the derivative of y squared with respect to y, which is just 2y, and I times that by dy by dx. And this is just going to be 2y. The right properly. And I'll look it out of the way and let the questions. So what I just did is to take the derivative of y squared. It's 2y times dy by dx. That's what the derivative is. That's the derivative of y. Dy by dx is the derivative. This is called the derivative of y. Like this right here. Right, that's like f prime of x. It's dy by dx. Because we have to still solve it. So if I can solve the dy by dx, what am I going to do? First I have to do it, right? So dy by dx. Negative 2x, okay? I'm just saying here dy by dx. So that's 2y equals negative 2x. Okay? So what's dy by dx when you equal that? Dy by dx is going to be? Maybe that's good one. I'll do it 2 steps. And that makes sense when you think of a circle. Okay? The slope of a circle, if you think of a circle, it's going to be affected both by the x and the y values. Right? The slope of what's going to happen for a circle isn't just going to be based on what the x value is. It's going to be based on both the x and the y values. You guys want to do the best by this? Let's get the best by the next example. I'm going to pause it. You guys can ask questions. Ask questions here, but stop. That's good.